Hello everyone. So today the lesson is going to focus on going through a couple AICE questions. So these are AICE questions right off the AICE exam. So these are like what you'll see mostly through chapter 12. So now that we've done chapter 6, 7, and 12, we're going to spend a little bit of time on what we learned with chapter 12 before we move on and do the second part of chapter 12. Okay, so from derivatives, you're going to get two types of AICE problems. So the first type is going to be dealing with stationary points. Okay, so that's what we're going to look at today. So let's go ahead and get to the first example. Okay, so here's our question. We have the shape, a square, and then a semicircle. So the diagram shows a metal plate that consists of a rectangle with sides x and length y, and then a quarter circle of radius x. Okay, the perimeter of the entire plate is 60 centimeters. So the perimeter, remember, is the outside. Okay, so part I, express y in terms of x. And then double I, show that, just to say, show that the area of the plate is given by this expression. And then find the value of x, for which a is stationary. So that's where our stationary point is going to come in. And then determine its nature. Find the stationary point and then determine its nature. So this is just finding the x value for the stationary point. This is finding the actual stationary point. And then remember, nature means maximum or minimal. Okay, so here's where the derivatives are going to come in. The first two have to come just by using some information I give up here, and you might have to pull some previous information from like geometry, like dealing with area of shapes and stuff like that. Okay, so looks like quite a bit, and it is. The good news is a lot of these questions dealing with, if it's dealing with the shapes or stationary points, dealing with some type of shape, they're going to be structured just like this. Okay, these two are helping you set up the equations that you're going to take the derivatives of. Because see, there's no equations in here. If you got to take the derivative, you got to have an equation. So that's what these two are helping you do. They're helping you set up the equations that you're later going to take the derivative of. Okay, so let's go ahead and get started with that. Okay, so the diagram shows a metal plate. So there's a key piece of information they tell us. Well, there's a few. They tell us the lengths, okay? But they also tell us the perimeter of the plate is 60 centimeters, okay? So P is 60. That's one thing we know. Now, what is perimeter? Perimeter is just adding up all the sides. Okay, so what two shapes make up this side? Well, we have a square and we have a quarter circle. All right, what's the perimeter of a square? So we add up the sides. Now, this dotted line does not factor into the perimeter. Remember, perimeter is outside. So the parts of the square that contribute to the perimeter are this side, and this side. So this is length y. So this is length y, and this is length x. So perimeter of square is adding up all the sides that contribute to this shape. Oops, sorry about that. Okay, now what about the perimeter of the circle or the semicircle? So perimeter of a circle is 2 pi r. Okay, the r, the radius, they tell us is x. So 2 pi x. But this is for a full circle. We don't have a full circle. What do we have? We have a quarter circle. All that means is we just divide this by 4. Okay, which makes that 1/2 pi x. Okay, but that's just for this part. Okay, that's just for the curved part, because that's only a quarter circle. Don't forget to add in this little x here. Okay, So perimeter of circle is 2 pi. That's the outer circle part. So that, but because we're only dealing with a quarter circle, we divide it by 4. So that gives us basically the arc length. Okay, but you can't forget about this side here. Okay, so where we flattened out, where we cut the circle off. So we have to add that length as well. Okay, so now the perimeter, we have y, x, the 1/2 pi x, y, and x. So the perimeter of the plate is, we have x plus 2y plus 1/2 pi x plus x. Okay, so I just added all 5 of those terms up. Now we know the perimeter of the plate is 60, so we go ahead and set this equal to 60. And you can go ahead and simplify this a little bit. Okay, so we have 2y plus x plus 1/2 pi x plus x. So we combine the x's, so we get 2x plus 2y plus 1/2 pi x. Okay, I can combine those x's. I can't combine these x's because it has the pi with it, and it's a little weird trying to add that up. Okay, so I set that equal to 60. So there's my expression I got from just using information I know about how to find perimeter and what they tell me the perimeter is. Now, what do we have to do with this though? Express y in terms of x. Okay, they don't tell you where to get y and x from. That's the stuff they give you in the problem. Okay, they give us perimeter, so we're going to use perimeter. Here's my perimeter. Now I'm just going to rearrange this for y, basically. Okay, so I subtract this over, and then divide by the 2. Okay, so it's going to give me 30. It's going to make this a quarter, and just make this x. Okay, so there's my expression for y in terms of x. Comes from part I. Okay. All right, now double I. Show that the area of the plate is given by this expression. So now we'll think about area. Okay, so that's how all these are going to be set up. You start off with perimeter, and then you get area, or they might give you the area and then come up with a volume, or some combination of that. Okay, so think of area now. Area of a square and area of a circle. Okay, so the area of a square is length times width, which for us is x times y. Okay. Now what's the area of the circle? Area of a circle is pi r squared, but we're dealing with a quarter circle, so it's going to be 1/4 pi r squared. So 1/4, and the radius is x, so 1/4 pi x squared. Okay, so the area of the plate then is these two added together. Okay, so you can see, okay, we're kind of there, but what's different here? We have a y here. They have no y. Well, that's what part I was for. Express y in terms of x. So I'm going to replace this y with the y we got from part I. Okay? So we have a is equal to. So basically I'm just taking all of those 3 terms and distributing an x to those. Okay? So I got 30. What was our... So we get an x squared here minus an x squared. Okay? And then plus the 1/4 pi x squared. Oops, sorry. Made a mistake there. already distributed the x to those. Okay, so I have 30x minus 1/4 x squared pi minus x squared plus 1/4 pi x squared equals a. You can see here the negative 1/4 pi x squared and the plus 1/4 pi x squared go away, and we just have a equals 30x minus x squared. Okay, exactly what they want us to show. All right, triple I. Find the value of x for which a is stationary. Remember, stationary is when the derivative is equal to 0. Well, the derivative of what? Of the area. So we're going to use the area equation because they say for which a, the area, is stationary. So we're going to use this. So find a prime. Okay. So a prime is, take the derivative of 30x. Well, that's just 30. And the derivative of x squared is 2x. Okay, so remember how to find stationary points. Take the derivative. Simplify as much as possible. Take what's in the parentheses. Set equal to 0. So the x value of the stationary point is x equals 15. And because we're talking about centimeters here, I'll put centimeters. Okay. Now, part 4, find the stationary point. So that means we got to find the y value associated with that. And then let's determine its nature. All right, so if we have x, how do we get y? We plug that back into our y equation, or our original equation, not the derivative. So because we use this to take the derivative of, I'm going to use a in order to find my y, or my x, or sorry, my a in this case. So for x, I'm just going to plug in 15. So 30 times 15 minus 15 squared. Okay, so we get, oh wait, we gotta find the stationary point first. Okay, so let's do 30 times 15. So let me pull out my calculator here. So that's 450. And we're going to minus that by 15 squared, which is 225. Okay, and we should get a positive number because you can't have a negative area. And in this case, we get a is equal to 225. So the stationary point is also what you put for your stationary point. Now remember how to do maximum and minimum to find the nature. X values less than 15 and greater than 15. So for less than 15 and then greater than 15, you plug that into the derivative. And if the slope is positive and negative, then you have a maximum. If it's minimum, negative and positive, you have a minimum. Okay, so let's use something less than 15. Keep it easy. Use 0. 30 minus 0, well, that gives me a positive slope. All right, what about greater than 15? So use something that's got a 0 at the end, easy to calculate. So 20. 30 minus 40, that's a negative. So we have a positive slope and then a negative slope. So we have a maximum in this case. Okay, so that was the first example. Now let's look at another example. The equation of a curve is given where y equals x cubed plus px squared. Well, p is a positive constant. Okay, that's a plus sign, so it means a positive constant. So p is positive. Show that the origin is a stationary point, so 0, 0, on the curve, and find the other stationary point in terms of P. So this is a cubic. So it's one of those that's up and then down, or down and then up. So we know there's two stationary points. One of them we know is the origin. So first we have to show that. We have to prove to them that yes, 0, 0 is the origin. So if we're talking about stationary points, we got to take the derivative. Okay? And remember, we're doing all this in terms of P. So we don't know what P is. So we're just going to leave P as P. So y prime, 3x squared, plus 2px. Okay? So if the stationary point is at the origin, we know x is equal to 0. So if it's a stationary point, remember stationary point is when the derivative is equal to 0. So if this is a true stationary point, when I plug this in there, I should get 0. And I get 0 plus 0 plus 0. So yes, we have a 0 slope when x is 0. So yes, the origin is a stationary point. So now let's find the other one. So to find the other one, we don't plug in anything for x. We go about this that we're going to solve for the stationary point. So remember, the first step is take the derivative, which we just did that. Second step is to simplify as much as possible. They both have an x in common. So I can pull that out. Stationary point, so it's equal, derivative is equal to 0. Solve for what's in parentheses. Okay, so there's the x value for the stationary point. How we get the y value? So they're asking for the stationary point. So the y value we plug this x value into the original. That's how we get our y value. Okay, this is not y, this is y prime. To get y, you have to use the y equation. So plug this into x here, and you get y is equal to, it's 4/27 p cubed. Okay, so there's the other stationary point. And it says in terms of p. So, all right, double I. Determine the nature. Okay, so you can think about this. So so the other one was the origin. So this one, because we don't know what p is, you can't really, solve this and get actual numbers. But you can think about this just graphically or visually. So the origin's obviously here. Now, remember, what was the one key thing they said about p? It was a positive constant. So that means no matter what p is, if it's positive, that means the x value here is a negative. All right, so it's going to be some negative value. And this means y is going to be some positive value. So it could be somewhere over here. Okay? It could be higher, it could be lower, but it's never going to be down here. So that means that one is our maximum, and then the origin is our minimum. Okay? So anytime you have a cubic, you can normally figure out which one's maximum, which one's minimum by just graphing them, rather than trying to do the taking x values less than and greater than and plugging them back in. Okay, so you have a problem to do today, or for an assignment. So it's very similar to the first one we did. The diagram shows the dimensions of a L-shaped garden. The perimeter of the garden is 48. So they're giving you the perimeter of this whole shape. Okay, remember, perimeter is just the outside, just these black lines. So find an expression for y in terms of x. Then show that the area of the garden is given by this equation. And then find the maximum area of the garden. So basically, triple I here is just combining triple I and part 4 like what we did in the first example.